Now today we are going to study about one part of the geometrical optics, and geometrical optics means we are trying to understand the phenomenon of ray optics through geometrical properties of light. It is one branch of the physics, and we are going to study about plane mirrors, and then we will go to curved mirrors, concave mirrors, convex mirrors. We can go to refraction from the curved surfaces, refraction through plane surfaces. We can go to lenses and all those part which involves a pure geometry. Now let us go to understand about plane mirrors. Plane mirror is nothing like this. We can say this is a plane mirror, and suppose I say this is an object kept. The light rays goes in this way, and the first phenomenon of definition of plane mirror, angle of incidence is equal to angle of reflection. And here we are going to understand about the properties of plane mirror by saying angle of incidence is equal to angle of reflection. We draw a normal to the incident ray. Normal means a perpendicular to the optical instrument, perpendicular to the plane mirror. So here we see that the light rays, and if we extend this and we join this, this is the image, and I can exactly say this is the one property of plane mirror. Like when a light ray strike on the plane mirror, it diverges, so an image is formed at this point. And we can have another phenomenon also in this way. Suppose this is a I draw a normal, and if I extend this, now here one thing I want to clarify. Here this is an object and this is the real object. This is very essential when we study about geometrical optics, and this is a virtual image. And if you look carefully to this diagram, this image will be a real image. And this is, we can say, virtual object. That means in case of plane mirror, we can say a real object forms virtual image, and we can say a virtual object forms real image. This is the one phenomenon we should always think about when we go to plane mirrors. In other optical instruments we will have this kind of phenomenon too, but that's a later on case. We stick to our discussions to plane mirrors. The first we say angle of incidence is equal to angle of reflection, and I show you these two things where a real object is forming a virtual image, a virtual object is forming a virtual object means the rays are coming from very far away. So in ordinary terms we can say rays are coming from very far away. So we can say very far away the rays are coming, they are striking the mirror and they are converging. So here you can say it is a diverging property. That means when the rays are diverging, we can say a virtual image is formed, and here you can say the rays are converging. After reflection. Here also I can say the rays are diverging after reflection. So here the rays are diverging after reflection, a virtual image is formed. Here rays are converging after reflection, a real image is formed. So this is the basic way of explaining this plane mirror, and all the definitions now we will come across, or the problems that will come across plane mirrors will involve a lot of phenomena like this. Now let us, one thing here I want to mention, this is a virtual image. So I can make one thing over here. Human eye can't distinguish between real image and virtual image. That means if I say myself to be an ordinary person and where I don't know any knowledge of physics, so I can say I cannot distinguish between a real image and virtual image. But how can we distinguish between a real image and virtual image? A real image can be caught on screen, whereas virtual image can't be. So this is the main definition ordinarily and through the knowledge of ray optics. Our human eye cannot distinguish between a real image and virtual image, and whereas real image can be caught on screen, whereas virtual image cannot be caught on the screen. This is the one way of defining the plane mirrors, and this is the explanation between real image, real object, virtual image, virtual object. Because what our section of discussing problems related to IIT Mains and IIT Advanced will be through these definitions: vector, law of reflection, that is when we said angle of incidence is equal to angle of reflection and all those things. E2 cap is equal to E1 cap minus 2 into what is E2 cap? We will write E2 cap is unit vector along reflected ray, E1 cap unit vector along incident ray, and N cap is unit vector along normal. So for AIEEE, that means for JEE Mains, EAMCET and all those examinations, or any other state level examinations, you will find this kind of problems involved. They will give you a ray is incident, and they will give in a vector form, they will give a vector form of normal. So they will say find the unit vector along the incident ray. You can easily find out the unit vector along the reflected ray in this way by saying in the question, if unit vector along incident ray and normal unit vector is given, you can easily find out the unit vector along reflected ray by using this concept, and this is the dot product. Now the main thing we come across where we say, suppose I say this is a plane mirror and I say this is object, and obviously plane mirror says that object distance must be equals to image distance. So I say if this is, and I take this is object and this is image. So I say, let us say if I take this as the origin, obviously this distance, if I measure, it will be positive, and this distance will be nothing but it will be negative. So I can simply write x o that is vectorically whatever the distance I measure, obviously this distance will be positive and this distance will be negative. I differentiate this with time. I write v of o with respect to x equal to minus v of I with respect to x, and in bracket I write differentiating, I get this. Differentiating, I get velocity of o with respect to x will be negative of velocity of image with respect to x, and earlier we know that a relative is always difference between two velocities. So I write this will be velocity of o minus velocity of x, I take minus common, this becomes velocity of I minus velocity of x. So here I write like this, velocity of o minus velocity of x, I take the negative side inside, so this is velocity of x minus velocity of I. Now I can write, I take this velocity of image to this side, velocity of this side, I can write velocity of image is equal to so instead of x, I change it to be mirror. That will be very fine with us. So here I take this to be m mirror. It will be very easier for us to again reconcile things. So my hours expression of velocity of image comes out to be this one, and you should remember this. Velocity of image is equal to twice the velocity of mirror minus velocity of object in vector terms. Now if this mirror is at rest and if the object is going in this way, obviously image has to come in the opposite directions, and if the object is receding away from the mirror, obviously the image will recede away from the mirror. And while discussing questions later on, we have got set of questions, you will have this kind of problems related. This was one part of the plane mirrors where we discussed about the velocity of images in a plane mirror. I will just write the definition. Minimum height or minimum length of the mirror for a man to see its full length image is equal to h by 2, that everybody knows. And what is h? H is height of man. Now the question comes, where should be the mirror positioned from the ground? Because in all books or in all discussions, it's always mentioned that the minimum height of the mirror is nothing but equals to h by 2. You can prove it by similarity principles. You can have the height is nothing but h by 2. So here we can say mirror should be positioned at a height equal to half the height, half the distance from the ground to the eye level of man. That means if this height from here to here, whatever the height will be, that height, half of that distance should be the mirror positioned from the ground, such that the whole image of the man can be visible in the mirror. That's the one way where we need to have this kind of thing. Next is rotation of mirror or incident ray. Now case 1, this is a mirror, this is the incident ray and this is the reflected ray. There can be a situation that keeping the mirror constant, fixed, incident ray is rotated. This is the first phenomenon. Like incident ray can be rotated either in this way or incident ray can be rotated in the opposite direction. Now the incident ray is rotated counterclockwise. Now when the incident ray, I write when incident ray is rotated in one sense, then the reflected ray rotates in one sense by an angle theta. So I write here when incident ray is rotated in one sense by an angle theta, then the reflected ray rotates by same angle in opposite sense. This you have to remember. When incident ray is rotated in one sense by an angle theta, then the reflected ray rotates by same angle in opposite sense. That means here incident ray is rotating in the counterclockwise direction. So here the reflected ray will rotate in the clockwise direction, because angle made by the angle of incidence must be equals to angle of reflection. So whatever here if you look carefully, the angle made by the incident ray with the normal is increasing. So here the angle made by the reflected ray must increase, so it has to rotate in the opposite direction. This is keeping the mirror fixed, incident ray is rotated. Number 2 we can say, next I take this mirror, when mirror rotates in one sense by an angle theta, keeping the incident ray fixed, then the reflected ray rotates by same sense of an angle 2 theta. So when mirror rotates in one sense by an angle theta, keeping the incident ray fixed, then the reflected ray rotates by same sense of an angle 2 theta. That means here if I am rotating this mirror in a direction anti-clockwise, so obviously the reflected ray will rotate same anti-clockwise with an angle 2 theta. But generally when problems are involved, they won't give individually this case 1, this individually case 2. They will mix these two cases. Let us go with a simple problem thinking about it. This is a mirror and incident ray, and this is a reflected ray. Here it is given the incident ray is rotating with an angular velocity 2 radian per second. Mirror is rotating with an angular velocity 10 radian per second. So in this case I will write incident ray rotates in the direction anti-clockwise 2 radian per second, and mirror rotates same anti-clockwise 10 radian per second. Find angular velocity of reflected ray. So when these two kind of problems are involved, two kind of cases are involved in one single problem, so we will decide by taking one case individually, then I will join this or I will combine these two effects to find out the angular velocity of reflected ray. So first case 1 I am saying when incident ray is rotating with an angular velocity 2 radian per second in an anti-clockwise direction. Already we have studied earlier just before it, when incident ray rotates by an angle theta, the reflected ray will rotate with the same angle theta but in the opposite sense. So case 1 is omega reflected. Case 1, that is when incident ray is rotating, we will write here same 2 radian per second but in the opposite direction. And second case, when mirror is rotating with an angular velocity 10 radian per second in the same sense, then the reflected ray will rotate by the angular velocity 2 theta, that is 20 radian per second. In the first case, incident ray is rotating at an angle theta in the anti-clockwise direction. So reflected ray will rotate in the same angle 2 radian per second in the opposite sense. Second one, when mirror rotates at an angle theta in the same sense, then the reflected ray will rotate by an angle 2 theta in the same sense. So here also omega reflected I can write same 2 into 10 20 radian per second but in the same sense like this. So these two are opposite directions, so I can write net omega reflected. So I can write 20 minus 2, that is 18 radian per second in this direction. So finally the angular velocity of the reflected ray will be nothing but 18 radian per second in the anti-clockwise direction. So this was all about rotation of the mirror, either the rotation of the mirror or either the rotation of the incident ray. We have already studied about the first concept came about real object, real image, virtual object, virtual image. Next we discussed about the vector law of reflection. Next we studied about what should be the minimum height of the mirror or length of the mirror for the full length of the image of the man can be seen, and we discussed about where should the mirror be positioned such that the man can see the full length of the image in the mirror, and we discussed it should be equal to the half the distance from the ground to the eye level of the man. Now we discuss next segment we discussed about the rotation of either incident ray or rotation of either the mirror. Let us go with the next, the last part of the discussion of a plane mirror, which is very essential when we discuss this. And so next we will have number of images. Now in all books they write if 360 degree by theta is equal to even number, then the number of images will be n minus 1 or something like that. Let us go with the simple example, like saying, now these are two mirrors which are inclined at an angle of 30 degree, and this is the object which is making an angle of 10 degree with the mirror M1. Suppose I say this is mirror M1, this is mirror M2. So I write object makes 10 degree with mirror M1. So angle between the two mirrors is given as 30 degree and the object makes an angle of 10 degree with mirror M1. So this will be 20 degree. I write here 10 degree, I write here 20 degree. That means 10 degree is the object making an angle with mirror M1, 20 degree is the angle making an angle with mirror M2. Now the total angle is nothing but 30 degree. So here I go like this, 10 plus 30, 40. Then I will go here, 20 plus 30, 50. Then I will go 50 plus 30, 80, 40 plus 30, 70, 70 plus 30, 100, 80 plus 30, 110. Then I will go, this is 110 plus 30, 140. Now I shouldn't go further, stop when angle is equal to 180 degree or greater than 180 degree. That means if I am, and I will explain the physical significance how the things are happening. 170 degree plus 30 is nothing but greater than 180 degree, and here also 170 degree plus 30 degree is nothing but greater than 180 degree. Now whether I should subtract or not, add the last two angles. I will write add last two angles with angle between the mirrors too. So if you look carefully, I will add this 170 degree plus 170 degree plus angle between the mirrors is nothing but how much I will get. Now let us check out how the things are becoming. Oh, here we have done a mistake. 100 plus 30, it is 130 and it is 160, sorry. So if you look carefully, 170 plus 160, so here we will get exactly as 0, 6 and 7 is nothing but 30, 360. Now if adding this all angles come out to be 360 degree, then we can say images coincide. Images coincide, then number of images will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 minus 1. So I will write the images will be 12 minus 1. It is nothing but equals to 11. So 11 images. Now why I am doing this phenomenon? Because I explain the physical significance. If I take this mirror M1, object is making an angle 10 degree. So obviously the image will be exactly at this point. Now again that image will form a total angle how much with this mirror M2? If you look carefully, the total angle will be nothing but I can write 10 plus 30 is 40. I repeat once again, this object is making an angle 10 degree with M1. Obviously the image will be over here, which is nothing but if I take this angle will be nothing but 10 degree. And if I take that image, again that image can form an image of mirror M2. That image total angle with mirror M2 is nothing but 30 plus 10, 40. Similarly, the process continues. So what I did, since this object is making an angle 10 degree, so I keep on adding 30. Because here it is 10, this one will be I1. Suppose I say this I1 is nothing but 10. 10 plus again if this I1 acts as an object for mirror M2, the total angle will be nothing 10 plus 30, 40. Again this process continues. So what I do, I take, and if I go with the, suppose I say let us go with the mirror M2, object O is making an angle 20 degree with mirror M2. Obviously the image will be over here. And this one is making an angle obviously 20 degree. This image acting as an object for this image, acting an object for mirror M1, 20 plus 30, it will be nothing but 50. So what I did, this object 10 degree and 20 degree. So 10 plus total angle between the mirrors 30, 40. Here I am taking 20, 20 plus 30, 50. I keep on adding 50 plus 30, 80, 40 plus 30, 70, 70 plus 30, 100, 80 plus 30, 110, 110 plus 30, 140, 100 plus 30, 130, 130 plus 30, 160, 140 plus 30, 170. I will stop here. Stop. Why stop? Because if I add 170 plus 30, it becomes 200 degree, 160 plus 30, 190. So stop when angle is equal to 180 degree or greater than 180 degree. Add the last two angles with the angle between the mirrors. So 170 plus 160 plus 30, it comes out, if it comes out to be 360 degree, images coincide. Well, so number of images will, I will add them 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 minus 1 is equal to 11 images. So this is, let us go with a different example where if I add this all angles, it doesn't come out to be 360 degree. So how the angles will be, let us go with that. Now let us go with this kind of situations where this is M1 and M2 and angle between these two mirrors is nothing but 75. And obviously many books I have seen, they have written, they are writing n is equal to 360 by theta if it is not an divisible or something like that they write, and those are all the mathematical manipulations which I don't not exactly like. I don't like to take all these mathematical significances in physics. We will just work out through the logics how it can be solved. So if you look carefully, this object is making an angle 30 degree with this mirror M1 and it is making an angle 45 degree with the mirror M2. So I write here 30 degree and and on the top I write M1 and here I write 45 degree, here I write M2. Now angle between these two mirrors is 75, so 30 plus 75, it becomes 105. 45 plus 75, so 10, 7, 4, J 11, 120. Again I will write 120 plus 75, it crosses 195, and 105 plus 75, 180 degrees. Stop. So if you look carefully, how many number of images are formed? Images, if I add these two angles, I will stop here because 120 plus 75 is nothing but I can write 195 and 105 plus 75 is nothing but 180 degrees. So I said stop when the angles are greater or equal to 180 degree. I will add these two angles, 120 degree plus 105. and I will add this angle between these two mirrors 75. So I add all this 10, 1, 7, 2 jan 9, 1, 10, 1, 300. Now it is not coming 360 degree. So images do not coincide. So number of images I can 1, 2, 3, 4. That's all. Number of images is equal to 4. So this is the best way how you can have a number of images without dividing. It's quite often it's very easy when the things are getting divisible, but when it is not divisible, things become like that. So I take in this way, and they write it is a perpendicular bisector or it is not a perpendicular bisector. So if angles are already given, so you can easily go with this and stop when the angles are greater or just equal to 180 degree, and add these two angles and angle between the mirrors. If it is not coming to 360 degree, so images do not coincide, so the number of images will be equals to 4. Now in the next segment, this was all about number of images. We discussed about real object, real image, virtual object, virtual image. We discussed about the vector law of reflection. Now the last segment we will talk about angle of deviation. Suppose I say this is a plane mirror and this is a ray and this is the reflected ray. Let this angle be I. According to the law of reflection, angle of incidence is equal to angle of reflection. So now what this mirror exactly doing? If there would not have been any mirror, this ray would have gone straight like this. If I show by the dotted lines, the ray would have been gone straight. But since there is a mirror, presence of this mirror is turning this ray into this way, and this turning angle is known as angle of deviation. I repeat once more. If there would not have been any mirror, this ray would have come straight. Since presence of this mirror is turning the mirror by an angle, let us say this angle, delta. So this angle will be nothing but this total angle is 180 degree, this is 2i, so this will be pi minus 2i. This is known as angle of deviation. Now while solving problems, I go with this. Suppose I am running in this way, I am turning towards left. Again there would have been mirror. In what way I deviate, either left or right, taking right or any one of the deviations to be positive. If I take left to be positive, then right has to be taken negative, and I add all these angles to find out the net deviation. So here deviation is pi minus 2i. If I plot a graph between deviation and angle of incidence, and I will find when angle of incidence is 0, then the deviation is pi. So here I write case 1, when I equals to 0, deviation is pi. I equals to 0 means the ray will come in this way. There is no angle made with the normal. So when the incident ray is coming in this way, the reflected ray will go in this way. So deviation is nothing but pi. Number 2, I can have when I equals to pi by 2, let us say that how this will be, the ray is coming this way. If the ray is coming in this way, the reflected ray will be also like this. There is no deviation. So I can say here deviation is nothing but equals to 0. And if I plot a graph the graph will be definitely in this way. So, this is a graph where the deviation is decreasing and becoming 0 at an angle of incidence pi by 2. So, this was all about angle of deviation. I found many students thinking about, suppose the mirror would have been placed in this way, the object is placed in this way. Now, I have seen they take the image distance will be like this. It is wrong. Always remember, I will write one point over here. Mirror always reflect perpendicular component. That means, since this is the mirror, object is placed like this, take exactly perpendicular. This will be the position of image, not this one. Always remember in things in mind, always drop a perpendicular distance to the mirror, and from that point again drop a perpendicular distance such that this distance must be equals to this distance. So, this will be the position of the image from the mirror. This was all about discussions about plane mirrors we have discussed so far. One concept is real object, virtual image, virtual object, a real image. For the virtual image to form, rays should diverge after reflection, and for a real image to form, the rays should converge after a reflection from the plane mirror. We discussed about real object, virtual image, virtual object, real image, and we discussed about human eye cannot distinguish between real image and virtual image, but the definition is real image can be caught on a screen, virtual image cannot be caught on a screen. And next we discussed about the vector law of reflection, saying that E2 cap is equal to E1 cap minus 2 into E1 dot n cap. And next we went into the discussion about what is the minimum length of the mirror such that the person can see the full image in the mirror, that is nothing but equals to h by 2, where h is the height of the man, and the mirror should be positioned at a distance half of the distance from the ground to the eye level of the man. Next we moved into the velocities of images, where mirror is also moving and object is also moving. We got velocity of image is nothing but twice the velocity of mirror minus velocity of object. Next we discussed about the rotation of the either incident ray or either the rotation of mirror. When incident ray is rotated by an angle theta, keeping the mirror constant or keeping the mirror fixed. So, when the incident ray is rotated by an angle theta, in some sense the reflected ray will rotate with the same angle theta, but in opposite sense, keeping in one thing in mind, that angle of incidence must be equals to angle of reflection. Next is when we rotate the mirror keeping the incident ray fixed, then the if reflected ray will rotate by an angle of 2 theta in the same sense as that of rotation of the mirror, and we discussed a small problem related to that. In the next segment we discussed about the number of images formed, and we discussed of an idea how we can have by just adding and putting all those theoretical aspects, by adding all those angles and angle between the mirror, adding the last angles that we discussed, and we found out if it comes out to be 360 degree, then the images coincide, and if it does not come out to 360 degree, the images will not coincide. And this is the last where we discussed angle of deviation by saying angle of deviation is nothing but pi minus 2i, and we discussed the following cases: when I is equal to 0, deviation is pi; when I is equal to pi by 2, deviation is 0. And we discussed this graph. This graph is very essential For the IIT mains or advanced, it is very much essential of these things. And remember, all these experiments we are performing in an homogeneous medium here, because reflection doesn't depend on the kind of medium. When we go to refraction, where we will introduce refractive indices and lot of apparent depth and real depth will come into account, we will discuss in that way, and a lot of good problems are there where we can have the phenomena of plane mirrors. Next, we will discuss about some problems related to all those concepts. Let us go with this.